Okay, so let's take a look at the WASI PC second series NOV DEC 2025, okay, for elective maths question number 2. They're saying that find the gradient of a tangent to the curve x squared minus y squared plus 16 all squared minus 2x gives us 46 at the point 1 and then negative 2. So let's see how best we can do this easily. Now, someone can decide to expand the whole of x squared minus y squared plus 16 all squared, or you can use the chain rule to also simplify this. Let's say I'm using the chain rule for the first part here. What I'm going to do is to let u be equal to what I have in the brackets, which is x squared minus y squared plus 16 over here, all right? This is what I have. So to find the derivative of the entire expression, I'm going to have the derivative of u squared with respect to x, then times the derivative of u, which is what is inside the brackets with respect to x, then plus the derivative of negative 2x with respect to x, and this will be equal to the derivative of 46, where you know the derivative of any constant is 0, right? So we'll come back to the point later. So let's find the derivatives. Derivative of u squared gives us 2x squared minus y squared plus 16. Then multiplies the derivative of what we have in the bracket, which is u. This gives us 2x minus 2y plus 2y dy over dx, because y is a function. We are dealing with implicit function here. Then plus 0, because the derivative of any constant is 0. Then plus the derivative of negative 2s gives us negative 2, and then the derivative of 46 gives us 0. Okay, so we take time when we are doing the implicit function. All right, so now let's expand the first bracket. Let's use 2 to multiply through the first bracket. That gives us 2x squared minus 2y squared plus 32. This is going to be multiplied by 2x minus 2y dy over dx here. Then I have negative 2 equals 0, right? So now I'm going to multiply, or I'm going to expand the two brackets. So expanding the two brackets gives me 4x cubed, and then this gives me negative 4x squared y dy over dx, right? And then now I move on to negative 2y squared to expand. Negative 2y squared expanding gives me negative 4xy squared, and then to this one gives me positive 4y cubed dy over dx. Then I now come to 32. 32 also expands to give me 64x positive, and then I have negative 64 y dy over dx, and this is equal to 0. All right, so grouping them, let me start with the positive one. Grouping like terms, I have positive 4y cubed dy over dx. I have negative 4x squared y dy over dx. Then I have negative 64y dy over dx. Then I group the other ones to the right hand side of the equation. So this gives me positive 4xy squared. Then I have negative 4x cubed. Then I have negative 64x. Then I have my 2, positive 2 over here. Oh, so we left the positive 2 out over here. Okay, so let's quickly do that correction. I have negative 2 and this equal to 0, right? So we forgot to add that here. All right, so from this stage, what I'm going to do is to factorize my derivative of y with respect to x. So this gives me 4y cubed minus 4x squared y, then negative 64y, and this gives me 4xy squared minus 4x cubed minus 64x plus 2. So this is what I have after doing my factorization at the left hand side. Okay, so dividing both sides with the coefficient of dy over dx, this becomes 4xy squared, okay, minus 4x cubed minus 64x plus 2. And all this is going to be divided by 4y cubed minus 4x squared y minus 64y. So this becomes the first part of the solution, okay? Then I move on to the point where they are saying at the point I have x to be 1, y to be negative 2. So now I can quickly find my derivative, which becomes 4, I have 1, and then negative 2 all squared, minus 4, I have 1 cubed, minus 64, then 1, then plus 2. All this divided by 4 and then negative 2 all cubed, minus 4, 1 squared and then negative 2, then minus 64, negative 2. So we enter everything and then see how best our answer is going to be. So our derivative of y with respect to x will now be 4 multiplies 1 and also multiplies negative 2 with squared, minus 4 multiplies 1 exponent 3. Then we also have negative 64 multiplying 1, and then we also have positive 2. So this gives us negative 50 as our answer up there. Then our denominator, we have 4 multiplying negative 2 with an exponent of 3. Then we have 4 multiplying 1 with an exponent of 2, also multiplying negative 2 again. Then we also have 64 multiplying negative 2. All right. So this gives us 104. So simplifying this, we know dy over dx is the gradient of the tangent, all right? We know dy over dx is the gradient of the tangent, and this gives us there's 50. This gives us 25, negative 25 out of 52 as the correct answer. Negative 25 out of 52. So thank you so much for joining. Please follow the playlist for question number 3. Thank you.